Welcome to this explainer serving as an introduction to the Linux file system. If you've ever used Linux, or if you're just getting started, one of the first things that might leave you scratching your head is how it actually organizes files. It can feel, well, completely foreign. But today, we're going to decode the Linux file system hierarchy from scratch. We're going to navigate it together, visualizing the whole thing as a giant spatial tree. And I promise, once we map it out, it's going to make perfect sense. Here is a quick look at our roadmap. 1. The unified tree structure. 2. Navigating with file paths. 3. Commands and the core system. 4. Users and system settings. 5. Dynamic data and hardware. And 6. Bringing it all together with a complete file system. All right, part 1. The unified tree structure, starting at the root. Okay, let's dive into this. To really understand Linux, we kind of have to unlearn a bit of Windows. In Windows, you know how your files are scattered across separate drive letters, right? Like a C drive or a D drive. Well, Linux is totally different. In Linux, everything starts from a single directory known as the root directory, which is represented by a simple /. It organizes all your files and storage devices within this one unified directory tree. So there are no drive letters, just one beautifully organized tree branching out from that single root trunk. And this brings us to one of the most fascinating core philosophies of this operating system, the idea that everything is treated as a file. The crucial point here is that in Linux, this isn't just a fun metaphor. Hardware devices, system information, and even your running processes can all be accessed through the file system, literally as files within this single unified tree. We're going to see exactly how wild and powerful that is a little later in our tour. Moving right along, part 2. Navigating with file paths, rules of the road. So, to navigate the Linux file system, users work with paths. A path is really just the address of a file. First up, we have the absolute path. This starts directly from the root directory and specifies the complete, unambiguous location of a file or folder. You always know it's an absolute path because it starts right off the bat with that /. Take /home/john/documents, for example. It tells the system exactly where to go from the very beginning of the tree. Now, what's really interesting here is how much time you can save with a relative path. If an absolute path is the full address from the top, a relative path is based purely on your current location within the directory tree. So if you're already inside that John folder, you just type documents without the / at the front. It's a super simple shortcut, but man, it will save you a ton of keystrokes. All right, part 3, commands and core system. The engine room. Let's see what's under the hood.
Let's crack open our core toolbox directories. First is /bin. This directory stores essential command line programs required for basic system operation, like ls for listing files or cp for copying. Without this, you wouldn't have any commands to run. Right below it is /sbin, with that S standing for system. These are powerful commands meant only for the administrator or the root user for things like rebooting the machine or managing disks. Next up is /lib. These are essential shared libraries, basically helper code that the programs in bin and sbin need to function. Finally, there's /boot. This holds the Linux kernel and the bootloader files. It's exactly what your computer needs to start up. If this gets corrupted, well, your system won't boot. So generally speaking, we leave this folder alone.
Part 4. Users and system settings, living quarters and control panel. Here are the spaces you'll probably interact with the most. The /home directory contains personal files and folders for regular users. Each user typically has their own home directory where documents, downloads, and personal settings are stored. But the Supreme Administrator gets their own highly protected space at /root. Notice this is the home directory specifically for the root user, which is different from that single /root directory at the very top of the tree. And then we have /etc. Think of this as the master control panel. The etc directory contains system-wide configuration files. Administrators use this location constantly to manage system settings and services, all stored cleanly in plain text. Then there's the massive /usr directory. It's incredibly easy to look at USR and think it means user, but actually it stands for Unix System Resources. This is where most of the software you install actually lives, and it's brilliantly organized internally, almost mirroring the main root tree. Your main application files go into usr/bin, their helper libraries into usr/lib, and documentation into usr/share.
Part 5. Dynamic data and hardware, the nervous system.
First up here is the /var directory.
VAR stands for variable data, meaning everything in here is constantly shifting as the system runs. Most vitally, it contains var/log. If something ever goes wrong with your Linux machine, this is absolutely the very first place you look. All the system's log files are kept here. It also handles things like principals and system databases. It's just a highly active, busy directory.
In contrast, we have the /temp directory. Just like it sounds, this is for short-lived, temporary files that programs need for just a little while. Think of it kind of like a sticky note on your desk, right? It's super useful right now while you're working, but it's going in the trash tomorrow. The system usually deletes everything in here automatically when it reboots. So whatever you do, never ever store important files in TMP. Now, remember earlier when we said everything is a file? Well, here is that philosophy in action. /dev is for device files that represent your hardware components. Your mouse, your hard drives, they are all exposed as files here. /proc and /sys are honestly mind-blowing. They are virtual file systems. They don't actually exist on your hard drive. The Linux kernel generates them on the fly to give you a live window into your running processes and hardware state. And finally, /mnt and /media. When you plug in a USB drive, it doesn't pop up as an E drive. Instead, it gets attached or mounted directly into one of these folders right on our tree.
Let's also briefly touch on /opt. If you've ever installed a massive third-party application like a commercial video game or Google Chrome, it might end up here. Opt stands for optional software. It acts as a separate, reserved area that keeps these big, bulky applications completely self-contained. That makes them neat and easy to remove without scattering their files all over your beautifully organized system. Finally, part 6, the complete file system, bringing it all together. And this brilliantly illustrates exactly why Linux is so powerful. Look at how logical this whole thing is. Instead of scattered drives, we have the root at the very top. From there, it neatly branches into our commands in bin, our user spaces in home, our master settings in etc., and our live hardware connections in dev and proc. Everything has a specific, intentional place. Once you understand the purpose behind each folder, the command line stops being this intimidating black box and becomes an incredibly organized map. Understanding the Linux file system hierarchy is a fundamental step toward becoming comfortable with Linux administration and command line navigation. So armed with this map, which branch of the Linux tree are you going to open up your terminal and explore next? Thanks for watching this explainer. Keep learning, and I'll catch you next time.